Section 7. Plane modifications using gaze mechanics. Video 1. Generating custom mesh on the plane. In the previous section, we put together a foundation for our wearable AR app. Once we resolved the setup, we learned how to retrieve bounded plane data, and we then spawned spheres on the vertices using gaze mechanics to select the plane. We will start this section from understanding how we can generate mesh ourselves using the list of vertices we extracted in the previous video. Even though we will end up remaining within AR plane subsystem in manipulating material properties of the visualized planes, we would like to know principles of mesh generation. This way, you'll be able to make more than what AR Foundation has to offer. In this video, we would like to give you a practical walkthrough of the principles of generating a mesh. The general idea is as follows. We start off identifying the detected plane that we will use to generate the mesh. We extract the vertices as in the previous section and add them to a list. Note that the vertices detected planes are arranged in clockwise order. We then work out where is the center of the polygon and add it as the last vertex to our list. Mesh in Unity needs to have vertices and triangles defined to be valid. We will use the center as a common vertex for all the triangles of the mesh that we will be creating. Now we can define triangles. Note that you want to define the vertices of each triangle in clockwise order in order for the normal to be calculated as pointing at your direction. That's the face on which the material will be rendered if single-sided shader is being used. Triangles are defined as a list consisting of indices of vertices arranged in order. So we start off 1, 5, 0. In this case to denote the first triangle, then 2, 5, 1 to denote the second triangle. We add all those indices to a list. The number of items contained in the list needs to be divisible by 3. We then convert the list of vertices and triangles into arrays and assign them to the mesh. Now we will demonstrate the theory in practice. We will use the plane boundaries that we extracted in the previous section to generate a new mesh alongside the one visualized by the AR Foundation Plane Manager. Feel free to duplicate the scene from the previous section. The changes will not be dramatic. There are just a couple of things we want to address in the editor at the moment. Add mesh filter and mesh renderer to our interaction controller object. If you look at AR default plane, you can notice the mechanism is similar. We need an empty filter to host our generated mesh. For the sake of example, we will channel everything through one object, but it could make sense to instantiate separate objects for different types of planes or create a list of meshes to keep track of them. We also need to apply a material to our fresh mesh renderer, otherwise we won't be able to see our mesh. I will create a standard material and assign it in the inspector. Now open the camera raycast script. Inside of our successful session origin raycast block, we declare and initialize the current hit pose based on the pose of the raycast. Next, once we extracted the vertices from the bounded plane, we declare variables in which we will store x and z coordinates of the vertices. Inside the for loop, we iterate over all the vertices and we increment the sum x and sum z values. At the end, we will divide them up by the number of all the vertices to obtain the average x and z position, which constitutes the center of the plane. We can now construct the last vertex of our mesh, the center. As all y values are the same, we use hit pose y to establish the height of the center vertex. We add it as a vector 3 to our list of vertices. Now it's time to calculate the triangles that will make up our planes. As shown earlier, the triangles are constructed from ordered sequence of vertices indexes. So we create another for loop to establish this list, assuming that the central vertex connects all the triangles. We need to add another triangle to close the mesh, as it consists of vertex 0 and the last vertex of the original boundary. Making sure the vertices sequence for each triangle is arranged in clockwise manner to render on the right side in order to accommodate for a single-sided shader. Now we are ready to create our new mesh and fill it with our lists of vertices and triangles in forms of respective arrays. We declare a private mesh variable at the top of our class and then initialize it using the object's mesh filter. We will assign the lists of vertices and triangles to the mesh as its properties. To do that, the lists need to be converted to arrays. Done and dusted. Save the script. We are ready to test the app. I will switch off the plane gauge script on AR default plane, as you will not be interacting with AR Foundation planes now. In the app, we can see custom mesh generated on horizontal and vertical surfaces. Because we did not set any offset in y-axis, both layers overlap in a glitchy way. Also, the custom planes do not appear at the same time if we are moving to another surface. As mentioned earlier, we can address this by creating a list of meshes, but this leads to further tweaks, which have already been addressed by AR Foundation. In this video, we have learnt about the fundamentals of mesh generation and how underlying mechanics of translating AR-bounded planes to mesh operate. This approach arguably offers you more freedom, but also adds to issues you have to resolve. AR Foundation Plane Manager offers a set of methods allowing for smooth translation. Since we do not need two layers of planes, we can proceed with getting to know plane subsystem capabilities.